It is one of the most widely used metals in the world. Every day, more than 100,000 tons of copper are produced. China alone consumes more than 14 million tons per year. To obtain just 1 ton of copper, nearly 200 tons of rock must be extracted. But have you ever wondered how copper is made? We visited one of the largest mines in the world to discover how one of the most valued metals on the planet is obtained. Modern civilization could not function without it. This metal is present in almost every aspect of our daily lives. It is part of motors, heating systems, and the electrical cables that power our cities. Copper is one of the best conductors of heat and electricity. It has exceptional resistance to corrosion. It is very flexible and malleable and can be recycled indefinitely. But where does copper come from? Copper is found in the Earth's crust, in the most superficial layer of the planet, mainly in sedimentary rocks, and its extraction is a complex process that involves several stages. The first step is to identify areas with potential copper ore deposits. This requires geological studies, sample analysis, and prospecting techniques to find locations where copper is present in economically viable concentrations. The Chuquicamata mine stretches across the Atacama Desert in northern Chile. Surrounded by an arid and extreme landscape, this gigantic excavation is one of the largest open-pit copper mines on the planet. Every year, more than 300,000 tons of copper are extracted from millions of tons of rock. But before reaching the valuable ore, enormous layers of waste material must be removed. In some areas, the deposit reaches depths of 100 meters, requiring colossal machinery and tons of explosives. To extract the rock containing copper, a huge drilling machine is used to make about 130 holes, known as blast holes, each at least 16 meters deep, equivalent to the height of a 5-story building. In each hole, a powerful mixture of ammonium nitrate and fuel is inserted, along with a certain amount of a high explosive called ANFO, and then filled with inert material. From a safe distance, an operator activates the charges, detonating them in series. Each explosion is so powerful it could knock down an entire skyscraper. The time between each blast is about 2 milliseconds. This detonation pattern is designed to fracture as much copper-bearing rock as possible. Thanks to technology and carefully designed blasting patterns, the explosive energy breaks up the rock underground while minimizing material dispersion and dust. After the explosion, once it is completely safe to enter the mine, the loading of the ore begins. Giant shovels lift the material with their large buckets and deposit it into enormous mining trucks. 1 ton of ore is needed to obtain 6 kilograms of copper. Therefore, to get 1 ton of copper, nearly 200 tons of ore must be extracted. The excavators scoop up between 55 and 88 tons at a time. That rock contains less than 0.5% copper. The trucks are almost 7 meters tall and can carry up to 400 tons, enough to transport 300 cars. Because an open-pit mine is so large, its operation is managed from a control center located in a tower similar to those at airports, from where everything happening on site can be observed. But how is a piece of dark ore transformed into one of the most used metals in the world? Releasing copper from ore requires different techniques depending on whether the ore is oxide or sulfide. To process oxide ore, the rocks are stacked in special leaching areas. The material is placed around the edge of the mine to begin the leaching process, where it is sprayed with a diluted sulfuric acid solution. Over several weeks, the acid slowly filters through the rock, dissolving the copper. The copper ion-laden solution is collected in ponds and distributed to the processing plant. In a special channel, the copper solution is combined with an organic reagent and floats to the surface. Then an acidic solution is added to increase the copper concentration and make it electrically conductive. The solution is transferred to a series of tanks containing thin copper plates called cathodes. When an electric current is applied, the copper ions begin to deposit on the plates. In just 10 days, each one reaches a thickness of 2.5 centimeters and a weight of about 125 kilograms. The purity reaches 99.99%, which is essential if the copper is to be used in electrical products. Extracting copper from sulfide ore is a more complex process. It begins in a gigantic drum known as a mill. Inside, steel balls grind the wet rocks into fragments. Upon leaving the mill, the material passes through a perforated belt that separates the smaller pieces. These fragments continue to secondary mills, while larger stones return to the mill for another round of grinding. Once pulverized, chemicals are added to coat the copper particles, and a foaming agent is mixed in. The mixture enters flotation tanks, where air bubbles carry the copper particles to the surface. This copper-rich foam is collected and filtered to obtain a concentrate with a purity of 25 to 30%. The next step takes place at the smelting plant. The concentrate is transported by train to large yards where it is layered with silica sand, known as flux. This sand helps remove impurities during smelting. At extreme temperatures, the mixture turns into a molten liquid. The slag, composed of iron and other minerals, floats, while the copper sinks. At this point, the purity reaches 60%. It then passes to a second furnace, where the copper content rises to 98%. The molten residue is poured into a pile, a stream of glowing slag flowing like molten lava. As it cools, it solidifies and becomes part of the landscape. Meanwhile, a crane transports the molten copper to another furnace where the final purification takes place. The purity increases to 99.4%, and the molten copper is poured into molds, forming large rectangular slabs called anodes. These slabs are cooled with water sprays and solidify. A hydraulic cylinder ejects them from the mold, and an automated system moves them to a washing station where the mold release agent residues are removed. They are then sent to a refinery hundreds of kilometers away. At the refinery, maximum purity is achieved. The anodes are submerged in tanks with electrolyte and face thin metal sheets called cathodes. When an electric current is applied, pure copper